More and more of today's energy comes from renewable sources like wind and solar. However, this energy is not always available when you need it, and storing it is a key challenge. This tech snack shows you what's needed for a smart solution using silicon carbide devices in electric vehicles. Electric vehicles, or short EVs, can do so much more than driving you from A to B. When talking about the need to store energy, you can also imagine them as huge battery packs on wheels. They can power your home and even get you a cashback by selling stored power back to the grid. My name is Emily Wiggum, and today we're going to talk about a solution that can change the way we look at our electric cars: bi-directional charging. What technology is needed to design these sorts of smart vehicle solutions? A car spends 90% of its time parked doing nothing. The vehicle-to-everything technology can change that. Let's start with the vehicle-to-home technology, or short V2H. It allows you to use your EV battery to power your home. Solar-powered homes cannot generate electricity at night, so an EV can help by providing a secondary source of power if needed. So far for the homes. Now, vehicle-to-grid, or V2G technology. It's the process of feeding the energy stored in an EV battery pack into the grid and thus boosts the grid's energy to supply electricity during peak hours. Just like in the home example, the car can function as extra power source whenever weather-dependent renewable energy sources are not available. When the grid gets a bit low on energy, it can be easily topped up from all connected EVs through bi-directional DC fast chargers that can switch from charging your EV to feeding the grid and vice versa. An electric car with a few tens of kilowatt hours battery capacity is the perfect candidate for smart and green home systems and can help meet the EU goals of clean energy by cutting CO2 emissions. Accordingly, there is a great need to equip the EV and the charger with a bi-directional converter to allow the EV to act as a power source to the grid. There is a general trend toward the utilization of silicon carbide devices, also known as SiC devices, for bi-directional onboard chargers because of their higher system efficiency, as well as the potential for V2G and V2H solutions. The 1200-volt SiC MOSFET is an optimum device to choose over silicon IGBT for synchronous rectification bidirectional power topologies in AC to DC and DC to DC converters. SiC devices offer several advantages over silicon. Number 1. A 10 times higher breakdown field strength enables high blocking voltages in smaller die area than silicon. Number 2. Lower on-state resistance and lower off-state leakage currents than silicon results in a higher efficiency device. Number 3. Very low or no reverse recovery current with the ability to switch frequencies to 3 times or 3 to 5 times higher than silicon help to reduce the size and weight of capacitors and magnetics. Number 4. A 3 times higher thermal conductivity and the ability to withstand higher chip temperatures help reduce cooling requirements. These desirable qualities have enabled the use of SiC-based AC to DC and DC to DC converters to make the charger smaller, faster, and more efficient. Arrow Electronics offers the key components to support the V2G and V2H solutions through the broad portfolio of 1200-volt SiC MOSFETs with reference boards that ease design effort and shorten times to market. To learn more about the technical details, please visit us at PCIM Europe in Nuremberg in Hall 7, booth 525, where we will present different power solutions for automotive and industrial applications, or you can get in touch with your local Arrow sales office.